Welcome to our channel. We are so glad you found your way here. Let us help you fall asleep. Let's begin with the Anthropic Principle. Is the universe designed for the observer? Take a slow, deep breath in and release it. Let the weight of the day fade away as we embark on an unhurried, atmospheric journey through the wonders of the cosmos. Your mind is quiet. The universe is vast, and we are ready to explore. The Anthropic Principle encompasses a range of ideas that address the relationship between human existence and the fundamental characteristics of the universe. It posits that the universe's physical laws and constants appear finely tuned to allow for the emergence of conscious observers. This principle can be categorized into two main forms: the weak anthropic principle and the strong anthropic principle. The weak anthropic principle suggests that the observed values of physical constants are conditioned by the requirement for observers to exist. These values are not necessarily special, but rather a consequence of humanity finding itself in a universe where such conditions are met. The strong anthropic principle, in contrast, implies a more deliberate aspect, indicating that the universe must have properties that inevitably lead to consciousness and self-aware beings. In this context, it becomes essential to consider how the parameters of physics, such as the gravitational constant and the electromagnetic force, are intricately balanced. Small variations in these constants could render a universe incapable of supporting life. They establish an environment conducive to the development of complex structures. Through this lens, the universe transforms into a framework that supports inquiry into its very nature, beckoning exploration into how existence itself is interwoven with cosmic laws. The historical context of the Anthropic Principle finds its roots in philosophical discourse, tracing back to early thinkers who pondered the role of humanity within the cosmos. This exploration gained momentum during the Enlightenment, as rationalism and empirical observation began to shape the understanding of existence. Intellectual movements questioned the significance of human beings in an expansive universe, leading to varying interpretations of humanity's place in the grand scheme. The emergence of natural philosophy laid the groundwork for later scientific inquiry, where the interplay between the observer and the observed gained prominence. Figures such as Immanuel Kant and David Hume contributed to discussions on perception and reality, challenging the notion of an objective universe detached from human experience. These ideas evolved into more defined frameworks during the 20th century, as advancements in physics sparked profound shifts in understanding. Cosmologists and physicists began to articulate concepts that hinted at a universe fine-tuned for life. The realization that certain physical constants appear remarkably suited for the emergence of complexity prompted reflections on whether this alignment was mere coincidence or indicative of an underlying purpose. This inquiry has since opened philosophical debates that traverse the boundaries of science and metaphysics, suggesting that the observer's existence is intricately linked to the fundamental laws governing the cosmos. The role of observers in cosmology raises profound questions about reality itself. Their presence influences the interpretation of cosmic phenomena, suggesting that the act of observation is not merely passive. This interaction leads to intriguing implications for theories concerning the universe's structure and evolution. The physical laws that govern this region, including gravity and electromagnetism, operate independently of human perception. Yet, the significance attributed to these laws can vary based on observational context. In quantum mechanics, the observer effect highlights this duality, where measurement can alter the state of a system. The implications stretch beyond the microcosm, extending into the vast expanses of the cosmos. The cosmic microwave background radiation, a remnant of the Big Bang, serves as a historical record, shaped by the very entities that study it. This phenomenon aligns with the notion that the universe must permit conscious beings to arise, leading to a universe that seems finely tuned for life. Constants and forces appear delicately balanced, suggesting that slight variations could render existence impossible. The exploration of dark matter and dark energy further complicates this narrative. These enigmatic components dominate the universe's mass-energy content, yet remain elusive to direct detection. Their study underscores the observer's role in shaping our understanding of the cosmos. As interpretations evolve with advancements in technology and theoretical frameworks, the intricate balance of fundamental constants and initial conditions invites a deeper exploration. This fine-tuning argument posits that the universe appears meticulously calibrated to allow for the emergence of life. Variations in these constants, even minuscule alterations, could render the existence of complex life impossible. Gravitational forces, electromagnetic interactions, and the strong nuclear force all exhibit precise values. These parameters influence the formation of stars, the synthesis of elements, and consider the cosmic microwave background radiation, a remnant from the early universe, providing crucial insights into its evolution. This radiation reflects the uniformity and slight fluctuations necessary for structure formation. Without such conditions, the vast complexities of astrophysical phenomena would not emerge, suggesting an underlying order amidst apparent chaos. The possibility of multiple universes introduces additional layers to this discussion, proposing that our universe is one among many, each with varying constants. This speculative framework raises profound questions about existence and reality. The fine-tuning argument thus serves as a focal point for debates surrounding the nature of our universe and the role of observers within it, continually shaping the fabric of our understanding. Key parameters of the universe play a crucial role in determining its structure and behavior. Constants such as the speed of light, gravitational constant, and Planck's constant establish the framework within which physical laws operate. These values remain invariant across vast distances and time, providing a stable foundation for the interactions that govern matter and energy. Gravitational force, acting between masses, dictates the formation of celestial bodies and the movement of galaxies. Its influence shapes the orbits of planets around stars and the acceleration of objects toward one another. Electromagnetic forces, governing the interactions between charged particles, underpin the formation of atoms, molecules, and, while the strong nuclear force binds protons and neutrons within atomic nuclei, the weak nuclear force facilitates processes such as radioactive decay. Each of these forces is finely balanced. A slight variation in their strengths could result in a universe devoid of stars, planets, or even atoms. This delicate interplay of constants and forces invites contemplation about the likelihood of a universe that accommodates observers capable of pondering their own existence. The parameters observed suggest a highly specific environment conducive to the emergence of life, evoking questions about randomness versus intentionality in the cosmos. This inquiry not only deepens our understanding of physical reality, but also our place within it. The cosmological constant plays a pivotal role in the fine-tuning of the universe. As a fundamental component of Einstein's equations, it embodies the energy density of empty space. Its value influences the expansion rate of the cosmos, an essential factor in determining the structure and fate of the universe. A slight alteration in this constant would have profound consequences, affecting the formation of galaxies, stars, and fire. In this context, the delicate balance between gravitational attraction and the repulsive force attributed to the cosmological constant becomes apparent. If it were significantly larger, galaxies would fail to form, leaving a barren expanse devoid of complex structures. Conversely, a smaller value would lead to a rapid collapse of the universe, extinguishing the possibility of a stable environment for observers. Observations suggest that the cosmological constant is remarkably small, yet positive, allowing for a universe that is neither collapsing nor expanding too rapidly. This characteristic raises questions regarding the underlying mechanisms that govern its value. The fine-tuning observed lends credence to theories of a multiverse, wherein various constants yield different physical laws across disparate realms. Such considerations not only illuminate the intricacies of cosmic evolution, but also underscore the significance of this constant in shaping the universe we inhabit. It becomes a fundamental aspect of our understanding of existence itself. The gravitational constant plays a pivotal role in the formation and stability of structures within the universe. Its precise value determines the strength of gravity, influencing everything from the formation of galaxies to the orbits of planets. Variations in this constant would yield vastly different cosmic architectures, potentially rendering life as we know it impossible. The delicate balance of forces at play in this region fosters an environment conducive to the emergence of complex systems. Stars, tethered by gravity, forge the elements necessary for life during their life cycles. The process of nucleosynthesis occurs in their cores, where temperatures and pressures are sustained by gravitational forces. These elements are subsequently released into space upon a star's demise, contributing to the material needed for planetary formation. The gravitational constant governs these interactions, dictating the scale and longevity of stellar lifespans. The implications extend to planetary atmospheres, where gravity retains gases, creating conditions essential for sustaining life. A weaker force might lead to atmospheres too thin to support liquid water, while a stronger force could result in crushing pressures. In regions of greater gravity, the structural integrity of matter itself is influenced, shaping the evolution of potential life forms. This interconnectedness illustrates how the gravitational constant is not merely a number, but a foundational underpinning of the universe, shaping existence and allowing observers to ponder their place within it. Electromagnetic interactions serve as a crucial framework for understanding the universe, governing the behavior of atoms and molecules. This force dictates how particles interact, facilitating the formation of chemical bonds that underpin the complexity of matter. Light, an electromagnetic wave, plays a significant role in this dynamic. It carries energy and information across vast distances, illuminating celestial bodies and allowing for the synthesis of organic compounds essential for life. Within this region, the electromagnetic spectrum offers a vast array of wavelengths, each contributing uniquely to the chemical processes that sustain biological systems. Photosynthesis, for instance, relies on specific wavelengths to convert sunlight into chemical energy, demonstrating the seamless integration of light and chemistry. In this delicate balance, the properties of light determine the energy thresholds necessary for reactions, enabling the formation of diverse compounds. Chemical reactions, driven by electromagnetic forces, lead to the emergence of complexity. Molecular interactions give rise to the building blocks of life, establishing a foundation for evolution. This intricate interplay facilitates not only the development of life, but also the capacity for consciousness and observation. Within the broader cosmos, light acts as a messenger. It reveals the structure and composition of distant galaxies, offering insights into their formation and evolution. The electromagnetic force thus serves as a vital link between the observer and the universe, reinforcing the profound connection inherent in existence. Strong and weak nuclear forces are fundamental in maintaining the stability of atoms. The strong nuclear force binds protons and neutrons in the nucleus, overpowering the electromagnetic repulsion that exists between positively charged protons. This force operates at an incredibly short range, yet it is essential for the integrity of atomic structures. Without it, matter as it is known could not exist, and the universe would be devoid of the complex elements that give rise to stars, planets, and life itself. Weak nuclear force plays a crucial role in processes such as beta decay, contributing to the transformation of one type of particle into another. This mechanism facilitates the generation of heavier elements in stellar environments through processes like nucleosynthesis. The interplay between these two forces creates a delicate balance, ensuring the stability of atomic nuclei while allowing for the dynamic processes that fuel stellar evolution. In this region of existence, the stability offered by these forces enables the formation of diverse chemical compounds, which in turn leads to the emergence of complex biological systems. The intricate relationship between forces at the subatomic level underscores the remarkable precision of the universe's architecture. The characteristics of these interactions shape not only the physical properties of matter, but also the very conditions necessary for observers to arise and contemplate their place within this vast cosmic framework. Initial conditions serve as the foundational parameters that dictate the evolution of the cosmos. These parameters, established during the moment of the Big Bang, include temperature, density, and the distribution of matter and energy. Variations in these conditions directly influence the formation of galaxies, stars, and planetary systems. Their outcomes are not random, rather, they follow physical laws that govern the behavior of particles and forces. In this region of space-time, slight alterations in the initial density could lead to markedly different structures. For instance, a more uniform distribution of matter may result in a smoother universe, lacking the intricate formations of galaxies and clusters that are observed today. Conversely, a denser region could collapse under gravity, spawning black holes and neutron stars, altering the trajectory of cosmic development. The interplay of these initial conditions with the fundamental forces of nature creates an environment that is finely tuned for the emergence of complexity. Stars ignite nuclear fusion, generating elements necessary for life, while the expansion of the universe allows for the delicate balance between cosmic inflation and gravitational attraction. The interplay of these processes leads to an environment where observers can arise, equipped to ponder the very nature of the universe itself. This profound connection hints at the philosophical implications of existence within such a finely crafted framework. The multiverse hypothesis introduces an alternative perspective on existence, proposing that our universe is but one of countless others, each with its own set of physical laws and constants. This region of thought challenges the uniqueness of the Anthropic Principle by suggesting that if infinite variations exist, the emergence of observers is not a rare occurrence, but rather a natural outcome of statistical probability. Across this vast expanse, some universes may resemble our own, while others could be vastly different, characterized by varied dimensions, elemental compositions, and even entirely distinct forms of matter. They may exist in parallel or be separated by unimaginable distances, rendered inaccessible by the very nature of space and time. In this framework, each universe operates independently, governed by its own fundamental rules. The implications extend beyond mere speculation. They reshape our understanding of reality. If observers can arise in multiple universes, the significance of life within our own may be diluted, raising questions about the role of chance in our existence. Such theories invite a re-examination of the fundamental nature of reality, suggesting that what we perceive as unique could, in fact, be one among many. The exploration of these ideas continues to challenge our understanding of existence, consciousness, and the cosmos itself. Weak and strong anthropic principles represent two distinct interpretations of the universe's relationship with observers. The weak anthropic principle suggests that the universe's fundamental parameters must permit the existence of observers, as only in such a universe can they contemplate their existence. This perspective implies that the observed physical laws and constants are not unique or special, but rather a selection effect arising from the vastness of possible universes. In this context, it provides a framework for understanding why life can emerge in certain regions of the cosmos while remaining absent in others. Conversely, the strong anthropic principle posits that the universe must have properties that ensure the development of sentient life. This perspective leans towards the idea that the parameters are finely tuned, suggesting intentionality behind their values. Such a view raises profound questions about the nature of existence and whether it is inherently inclined towards the emergence of consciousness. It invokes discussions about the potential existence of a multiverse, where different regions exhibit varying physical laws, thus allowing for the possibility of life in at least one of them. Both interpretations provoke reflection on the implications of existence within this cosmos, prompting deeper inquiry into the nature of reality and our place within it. Each perspective offers a lens through which to examine the mysteries surrounding life and the universe. This principle suggests that the universe must contain the conditions necessary for the existence of observers within it. The arrangement of physical constants and laws appears finely tuned, yet it is simply a reflection of the selective nature of observation. In regions where conditions permit life, it is no surprise that observers arise to ponder their existence. The vastness of the cosmos reveals countless regions where such conditions do not prevail, leading to an apparent bias towards life in those pockets of reality. Statistical reasoning underpins this perspective. By considering the immense number of possible universes with varying constants, it becomes evident that observers will find themselves in those where conditions align favorably. This leads to the conclusion that the universe is not uniquely designed for life, but rather, life is a product of the specific conditions present in this instance. In this exploration, the multitude of universes, many lacking sentient beings, reinforces the notion of selection bias. The observable universe serves as a mere fragment of the larger multiverse, where the probability of life emerges through the randomness of its myriad configurations. Such insights bring forth a deeper understanding of existence, revealing that the seemingly improbable nature of life is a natural consequence of the statistical landscape of reality itself. The strong anthropic principle posits that the universe is not merely conducive to life, but must allow for its existence. This assertion implies a fundamental alignment between the laws of physics and the intricate conditions necessary for life to flourish. The fine-tuning of constants, such as the gravitational and electromagnetic forces, suggests that variations within these parameters would yield an inhospitable environment, devoid of complexity. In this context, the formation of stars and planets becomes more than a mere cosmic accident. It transforms into an essential requirement for the emergence of life. These celestial bodies, through their life cycle processes, contribute to the synthesis of heavy elements, which are critical for biological development. The presence of water, a remarkable solvent, is another indispensable factor, influencing the chemical reactions necessary for life. This notion extends beyond mere survival. It encompasses the intricate web of ecological interactions and evolutionary pathways that have led to the diversity of organisms observed today. Each adaptive trait, shaped by millennia of natural selection, reflects the underlying cosmic conditions that allow these forms of life to persist. Such interconnections reveal the profound relationship between the universe and its inhabitants, suggesting that the lines separating existence and consciousness are intricately woven into the very fabric of the cosmos. This perspective invites a contemplation of purpose within the vastness of space. The limits of observation in the universe arise from a combination of cosmic and physical barriers. The observable universe extends approximately 13.8 billion years into space, defined by the distance that light from the earliest moments of the cosmos has traveled. Beyond this horizon lies an expanse that remains forever inaccessible, hidden from view due to the finite speed of light. This constraint means that many regions remain unobserved, their contents unknown and perhaps unknowable. Cosmic expansion further complicates the landscape of observation. Galaxies recede from one another, driven by the expansion of space itself. For distant observers, this expansion creates a phenomenon known as redshift, where light waves stretch, leading to a shift toward longer wavelengths. Consequently, certain regions drift beyond the observable threshold, their light forever escaping our instruments. Local conditions also impose limitations. Interstellar dust and gas can obscure light, creating pockets where information is muffled or entirely blocked. These impediments highlight the complexity of gathering data in a universe that is both expansive and intricate, requiring sophisticated technology and methodologies to probe its depths. Understanding the boundaries of observation not only shapes our comprehension of the cosmos, but also inspires questions about the true nature of existence, propelling the quest for knowledge into the unknown. The cosmic microwave background radiation serves as a remnant signal from the early universe, a faint echo of the hot, dense state that existed approximately 380,000 years after the Big Bang. This radiation permeates the cosmos, a nearly uniform glow detectable in all directions, revealing the conditions of a nascent universe. It carries with it a wealth of information about the physical processes that unfolded shortly after the initial expansion. Temperature fluctuations within this radiation illustrate the density variations that seeded the formation of galaxies and large-scale structures. These patterns, measured with remarkable precisions, provide insights into the universe's composition, including the ratios of ordinary matter, and dark energy. The discovery of this background radiation in the mid-20th century marked a pivotal moment in cosmology, supporting the Big Bang theory and reshaping our understanding of cosmic evolution. Analyzing this ancient light continues to refine models of the universe's growth and fate, illuminating the conditions that led to the universe as it is known today. The study of the cosmic microwave background not only enriches the narrative of cosmic history, but also reinforces the interconnectedness of all cosmic phenomena, inviting further exploration into the nature of reality itself. The role of quantum mechanics in cosmology provides a fascinating lens through which to examine the universe. At its core, this branch of physics seeks to understand the behavior of matter and energy at the smallest scales. Quantum fluctuations, which emerge spontaneously in the vacuum, have profound implications for cosmic structure formation. These fluctuations seeded the density variations that later evolved into galaxies and large-scale structures. In this region of the universe, the principles of superposition and entanglement challenge classical notions of reality. Particles can exist in multiple states simultaneously, and their properties can be interconnected over vast distances. This phenomenon raises questions about locality and the nature of observation itself. The act of measuring a quantum state appears to influence its behavior, suggesting a complex relationship between observers and the cosmos. Quantum mechanics also plays a pivotal role in the early universe. The inflationary model posits that a rapid expansion occurred moments after the Big Bang, driven by quantum energy fields. This expansion smoothed out irregularities, leading to the large-scale uniformity observed in the cosmic microwave background. As such, the interplay between quantum mechanics and cosmology reveals a universe that is not merely a backdrop for life, but rather a dynamic entity shaped by intricate processes. Exploring these interactions deepens understanding of the cosmos and our place within it. Cosmic inflation presents a foundational concept in understanding the expanding universe. Occurring just moments after the Big Bang, this rapid expansion transformed the nascent cosmos. Initially, it underwent exponential growth, which smoothed out any irregularities, creating a near-uniform background of cosmic microwave radiation. This phenomenon laid the groundwork for the large-scale structure observed today. The implications of this expansion are profound. It suggests that regions of space, now vastly distant from one another, were once in close proximity, sharing physical properties and energy. It explains why the universe appears homogeneous on large scales, while still accommodating the diverse structures observed, from galaxies to galaxy clusters. Fast as the universe continues to expand, it is gradually driven by dark energy, a mysterious force that accelerates this growth. Current measurements indicate that this expansion is not just ongoing but intensifying. Observations reveal the universe's fate may lead to a state known as the Big Freeze, where galaxies drift further apart and stars extinguish over trillions of years. These processes encourage contemplation of the universe's fine-tuning for observers. Life, as it is known, can only exist within a specific set of conditions. The vastness and intricacies of this expanding cosmos prompt questions about existence itself, challenging perceptions of time, space, and the nature of reality. This exploration leads to the Anthropic Principle, a concept suggesting that the universe's fundamental parameters are finely tuned for the emergence of observers. Within the framework of quantum field theory, it becomes evident that the constants governing physical interactions are not arbitrary. Instead, they appear to be aligned with conditions conducive to the development of conscious life. Quantum field theory posits that particles are excitations in underlying fields. The specific values of these fields dictate the behavior of matter and energy, shaping the cosmos. Variations in the strengths of fundamental forces, such as electromagnetism and gravity, would result in radically different realities, potentially devoid of life as understood. The precision observed in these constants evokes contemplation. This principle suggests that observers are not merely incidental, but rather integral to the universe's structure. The implications extend to the multiverse theory, where countless realms exist with varying parameters. In such scenarios, it remains probable that only some universes could support intelligent life. Such reflections on existence within quantum field theory reveal a profound relationship between consciousness and the cosmos. The understanding of these connections invites deeper inquiries into the nature of reality, existence, and the laws that govern this vast expanse. Each discovery continues to unravel the threads of knowledge, reshaping the narrative of the universe. The origin of the universe traces back to a singular event known as the Big Bang, approximately 13.8 billion years ago. This moment marked the beginning of time and space, initiating a rapid expansion that would give rise to galaxies, stars, and planets. Cosmic inflation, a period of exponential growth, set the stage for the subsequent cooling of matter and the formation of subatomic particles. As the universe continued to expand, hydrogen and helium emerged as the primary elements. Over millions of years, these gases coalesced under gravity to form the first stars. Stellar nucleosynthesis occurred within these celestial bodies, generating heavier elements. Supernovae, the explosive deaths of massive stars, scattered these elements across the cosmos, enriching the interstellar medium. And galaxies began to cluster, creating vast structures governed by gravitational forces. Within this framework, planetary systems formed around stars, including one in a quiet corner of the Milky Way. The Earth, positioned in the habitable zone, became a cradle for life. The evolution of this planet unfolded over billions of years, leading to the emergence of complex organisms. Life adapted and diversified, culminating in the presence of intelligent observers capable of pondering the universe's origins and their place within it. Each step in this vast timeline contributes to an ever-deepening understanding of existence itself. The emergence of stars plays a critical role in shaping habitable conditions across the cosmos. These radiant spheres of nuclear fusion provide not only light, but also energy essential for the development of complex ecosystems. In the heart of a star, hydrogen atoms collide and fuse, releasing immense amounts of energy. This process creates a balance between gravitational forces and outward pressure, resulting in stability that can last for billions of years. Within the habitable zones of these stars, temperatures allow for the presence of liquid water, a fundamental ingredient for life as currently understood. The delicate equilibrium maintained by a star's energy output fosters environments where various chemical reactions can occur, leading to the formation of organic compounds. These compounds serve as the building blocks for life, facilitating the emergence of diverse biological entities. Solar systems orbiting around stars exhibit a range of potential climates and atmospheric compositions influenced by distance and stellar type. The variations among these systems contribute to a rich diversity of planetary environments. These environments, in turn, can lead to unique evolutionary pathways. As stellar life cycles progress, they enrich the surrounding space with heavier elements through processes such as supernovae. This enrichment further enhances the potential for new star and planet formation, thus perpetuating the cycle of existence. The conditions necessary for life emerge from the intricate processes occurring within young stellar systems. Once a star ignites, its surrounding protoplanetary disk begins to coalesce, allowing dust and gas to aggregate into larger bodies. This region becomes a crucible for planet formation, where temperature gradients and chemical compositions dictate the nature of these nascent worlds. Within this zone, the delicate balance of distance from the star plays a crucial role. Terrestrial planets, situated closer, experience intense heat, leading to rocky formations. This proximity facilitates the development of atmospheres, albeit thin, composed of elements such as carbon dioxide and nitrogen. Further out, gas giants form, accumulating vast quantities of hydrogen and helium. Their immense gravitational fields enabling them to capture surrounding materials. The presence of water, often a precursor to life, can be traced to the icy bodies that drift in the colder outer regions. These comets and asteroids, rich in volatile compounds, can be drawn inward during collisions, delivering essential ingredients to terrestrial planets. Such events create an opportunity for biochemical processes to unfold, setting the stage for the emergence of living organisms. In these diverse environments, the interplay of physical and chemical factors leads to a rich variety of planetary conditions, some of which may foster life, while others remain barren and inhospitable. These extremes challenge traditional definitions of habitability. In the harshest environments on Earth, extremophiles thrive, showcasing the resilience of life. From the boiling waters of hydrothermal vents to the icy expanses of Antarctica, organisms adapt to conditions once deemed unlivable. These adaptations include unique metabolic pathways and cellular structures that protect against extreme temperatures, acidity, or salinity. Such discoveries prompt a reconsideration of where life might exist beyond Earth. The presence of extremophiles suggests that life could potentially survive in environments previously thought inhospitable, such as the sulfuric acid clouds of Venus or the icy moons of Jupiter and Saturn. This expands the search for extraterrestrial life, guiding space missions to explore these extreme locations. The implications extend into the realm of astrobiology, where the characteristics of extremophiles inform models of potential life forms on other planets. Understanding how these organisms endure extreme stresses helps scientists predict the biochemical basis of life elsewhere in the universe. As the study of extremophiles continues, it reveals not just the adaptability of life, but also the intricate connections between biology and the cosmos. The resilience of life forms in extreme conditions highlights the potential for a universe teeming with diverse ecosystems, challenging the anthropocentric view of life and its origins. The potential for a universe teeming with diverse ecosystems opens up inquiries into the existence of extraterrestrial life. Central to this exploration is the Drake equation, a mathematical formula developed to estimate the number of active, communicative extraterrestrial civilizations within the Milky Way galaxy. While the equation comprises several variables, each representing different factors necessary for the emergence of intelligent life, it serves as a framework for contemplating life beyond Earth. The equation factors in the average rate of star formation, the fraction of stars with planetary systems, and the number of habitable planets per star that could support life. Each of these elements reflects the vast cosmic conditions that may foster life. The apparent frequency of exoplanets and habitable zones around their stars suggests that numerous opportunities for life exist. Despite its speculative nature, the Drake equation emphasizes the importance of understanding the cosmos and our place within it. It invites consideration of the diversity of planetary environments and their potential to harbor life. Current advancements in astrobiology and planetary science continue to refine these estimates, leading to discoveries that challenge existing paradigms. The search for biosignatures and the study of extremophiles bolster the notion that life might be more common than previously thought, reinforcing the curiosity about other civilizations that may inhabit the universe. The curiosity regarding other civilizations aligns with the fundamental nature of the universe itself. Dark matter and dark energy comprise approximately 95% of the cosmos, yet they remain elusive to direct observation. This region of existence holds mysteries that drive scientific inquiry. The gravitational effects attributed to dark matter are evident in the rotation curves of galaxies, where stars orbit at speeds that defy expectations based solely on visible matter. It influences the large-scale structure of the universe, shaping the cosmic web with its unseen presence. Dark energy plays a distinct role, contributing to the accelerated expansion of the universe. This phenomenon, discovered in the late 20th century, suggests that the fabric of space itself is stretching. As galaxies drift farther apart, the implications for the fate of the cosmos become profound. Whether this expansion will continue indefinitely or eventually reverse is a crucial question in cosmology. The exploration of these components not only reveals the universe's architecture, but also indirectly informs the anthropic principle. The conditions that allow for the emergence of observers seem intricately linked to the balance of forces and energies within this vast expanse. What remains is the quest to understand how these dark entities interact with known matter and energy, shaping the cosmos in ways still beyond the reach of current comprehension. The conditions that render a planet suitable for life encompass a variety of factors, each contributing to the delicate balance necessary for sustaining biological processes. Temperature plays a crucial role. It must fall within a specific range to allow for the existence of liquid water, a fundamental solvent for biochemical reactions. This range, often referred to as the habitable zone, varies depending on the star's characteristics and the planet's atmospheric composition. Atmospheric pressure is equally significant. A sufficient gravitational pull is required to retain an atmosphere that can shield the surface from harmful radiation while maintaining essential gases such as oxygen and nitrogen. These gases are vital for respiration and other metabolic functions. The presence of a magnetic field can provide additional protection, deflecting charged particles from solar winds that may strip away an atmosphere over time. The geological activity of a planet also contributes to its habitability. Volcanic processes can replenish necessary gases and nutrients, while tectonic activity can create diverse ecosystems. Presence of organic compounds, the building blocks of life, further enhances the potential for life to flourish. In this exploration of habitability criteria, it becomes evident that the universe, while vast and enigmatic, operates under principles that may be a reflection of the conditions necessary for life. This raises profound questions about the absence of extraterrestrial civilizations, a dilemma encapsulated in the Fermi paradox. Given the immense scale of the cosmos, with billions of stars and potentially habitable planets, the silence from other intelligent beings is striking. Various hypotheses attempt to explain this phenomenon. One possibility is that civilizations may emerge and extinguish themselves before they can establish contact. The timeline of technological advancement and the fragility of existence could lead to a series of fleeting moments of intelligence, each extinguished before it can reach out. Another theory suggests that the vast distances between stars create insurmountable barriers to communication and travel. Interstellar distances are daunting, and the energy required for such endeavors exceeds current technological capabilities. The enormity of space may render contact improbable, even among civilizations that thrive concurrently. Alternatively, it is conceivable that other intelligent life forms exist but choose not to reveal themselves. This could stem from a variety of motives, including self-preservation or ethical considerations regarding interference with emergent civilizations. Consequently, the silence from the cosmos invites profound contemplation about the nature of existence, the potential for life beyond Earth, and the delicate balance required for civilizations to endure within the expansive universe. The intricate processes of chemistry serve as the foundation for life itself, influencing the formation of complex molecules essential for biological existence. In this region of the universe, carbon emerges as a central element capable of forming diverse compounds that facilitate the intricate reactions necessary for life. The versatility of carbon, combined with the presence of water, creates environments where organic molecules can assemble. Thus, these chemical interactions are not isolated occurrences. Rather, they unfold within specific conditions that include temperature, pressure, and the availability of essential elements. The primordial soup hypothesis illustrates how the right combination of these factors may have catalyzed the first organic compounds on Earth. Such conditions, replicated in various forms throughout the cosmos, suggest that the emergence of life might not be unique to our planet. Astrobiological investigations have turned their attention to extreme environments, such as hydrothermal vents and subsurface oceans on icy moons, where life may thrive under conditions previously deemed inhospitable. The exploration of these environments highlights the resilience of biochemical processes and their adaptability. Understanding the role of chemistry in life's emergence provides insight into not only our origins but also the potential for existence elsewhere in the universe, where similar processes may unfold, shrouded in silence and mystery. Exploration for extraterrestrial intelligence extends beyond mere conjecture, grounding itself in rigorous scientific inquiry. This initiative, known as the Search for Extraterrestrial Intelligence, involves scanning vast expanses of the cosmos for signals that might indicate the presence of intelligent life forms. Faced with immense distances and the limitations of current technologies, researchers employ advanced algorithms and sophisticated radio telescopes to sift through cosmic noise, seeking patterns that stand out against the backdrop of silence. Several projects operate under this auspice, utilizing a network of observatories scattered across the globe, each contributing to a collective effort. These instruments listen intently for narrow-bandwidth radio signals, which are often theorized to be the hallmark of intelligent communication. The likelihood of detecting such signals hinges on the assumption that other civilizations might utilize similar methods of communication, an assumption rooted in our understanding of physics and technology. Despite a lack of definitive evidence thus far, the search remains persistent and methodical. Each new discovery in astrophysics and planetary science fuels curiosity, expanding the parameters of where life could exist. The identification of exoplanets in habitable zones reinforces the notion that the conditions conducive to life are not unique to Earth. As the quest continues, each data point collected contributes to the broader understanding of existence within this vast and enigmatic universe. The Anthropic Principle introduces a profound philosophical inquiry into the nature of existence, suggesting that the universe's fundamental parameters appear finely tuned for the emergence of life. This principle implies that the physical laws and constants observed are not random, but rather conducive to the formation of an observer capable of pondering such questions. Such parameters include gravitational forces, electromagnetic interactions, and the intricacies of nuclear forces that govern atomic behavior. In scrutinizing these conditions, it becomes evident that minor adjustments in any of these constants would render the cosmos inhospitable to life as it is known. This observation raises critical questions surrounding the nature of reality and the role of consciousness within it. The philosophical implications extend to discussions of purpose and meaning, with some interpretations suggesting a universe that is inherently predisposed for the existence of intelligent life. This perspective invites a re-evaluation of the relationship between the observer and the cosmos. Rather than viewing the universe as a random collection of matter and energy, it can be perceived as a complex structure that somehow aligns with the processes that support conscious beings. The exploration of this principle influences not only scientific discourse but also theological and existential reflections, intertwining the realms of empirical inquiry and philosophical contemplation. Such intersections continue to inspire dialogue across disciplines, deepening the understanding of existence itself. Theological implications emerge prominently when examining the Anthropic Principle, suggesting a universe intricately aligned with the possibility of observers. This alignment raises profound questions regarding creation, purpose, and the nature of existence. The idea that the cosmos exhibits a fine-tuning conducive to life invites reflections on divine intention. In various theological frameworks, this fine-tuning is interpreted as evidence of a guiding intelligence. The observation that numerous physical constants appear precisely calibrated fosters a dialogue between science and spirituality. This region of inquiry often leads to considerations of whether the universe exists solely for human perception or if it encompasses broader dimensions of consciousness. Universal laws, which govern the behavior of matter and energy, prompt debates about the role of an omnipotent creator versus the inherent capabilities of the cosmos itself. In addition, the principle invites interpretations that question the randomness of cosmic events. The delicate balance of conditions necessary for life challenges purely materialistic explanations, prompting discussions about the potential for a purposeful design. These reflections resonate within various religious traditions, each offering unique insights into the relationship between the observable universe and the divine. The intersection of science and theology remains a rich field for exploration, as these inquiries continue to shape our understanding of existence and the nature of the observer. Ethical considerations emerge when contemplating the human perspective within this vast universe. The notion that existence may be tailored for observers compels reflection on the responsibilities inherent in such a privileged position. This awareness can influence behaviors, guiding humanity toward a more sustainable coexistence within the cosmos. The awareness of being part of a finely tuned environment stirs a sense of stewardship. It fosters a deeper connection to the natural world and an obligation to preserve its systems. Each ecosystem, each species plays a critical role, contributing to the overall fabric of life. The fragility of these connections underscores the ethical imperative to safeguard them. Human actions, whether through technological advancement or industrial expansion, have not only altered landscapes but also the delicate balance of planetary systems. This awareness of consequence raises ethical dilemmas about progress and preservation. It invites consideration of future generations, emphasizing the need for choices that reflect long-term sustainability rather than immediate gain. In contemplating the universe's design, the potential for a moral framework rooted in cosmic awareness becomes evident. Such a framework encourages humility and respect for the complexities of existence. As humanity continues to explore its place, these ethical considerations shape not only individual choices, but also collective pathways forward. The inquiry into the universe's intention transcends mere curiosity, revealing the profound implications for human behavior. The Anthropic Principle suggests that the universe's fundamental parameters appear finely tuned to allow for the existence of observers. This notion prompts a deeper exploration of reality, where the constants of nature, such as the gravitational force and the electromagnetic interaction, seem remarkably conducive to life. Within this context, it becomes evident that these specific values are not arbitrary, but may indeed reflect a broader framework that supports consciousness. In regions where stars ignite and galaxies swirl, the conditions necessary for life emerge. This delicate balance between forces creates environments suitable for complex structures. The vastness of space, with its cold emptiness, provides contrast to these life-sustaining pockets, emphasizing their rarity and fragility. The temperature, density, and composition of matter in the cosmos are aligned in such a way that the formation of planets, and subsequently life, is conceivable. Investigating these constants raises questions about the very nature of reality. Are they fixed, or could they vary across other regions of existence? The implications of such variability challenge the understanding of life's uniqueness. Each observation made by conscious beings adds layers to the comprehension of the cosmos, suggesting that the universe is not only a physical entity but also a participant in the act of observation itself. The interplay between existence and understanding shapes the ongoing dialogue surrounding the Anthropic Principle. Enter Anais. The role of mathematics in understanding the universe provides a fundamental framework through which patterns and relationships can be discerned. It offers a language that transcends cultural and temporal boundaries, allowing for the expression of complex theories and observations. Equations emerge as concise representations of natural laws, encapsulating vast phenomena within elegant symbols and numbers. This precision enables scientists to predict outcomes, revealing the underlying order present in seemingly chaotic systems. These mathematical constructs describe everything from the motion of celestial bodies to the behavior of subatomic particles. In this region of exploration, concepts like calculus and geometry are essential tools, illuminating the pathways of light and the curvature of space-time. Each equation serves not only as a means of calculation, but as an invitation to deeper inquiry into the nature of reality. The application of mathematical models has led to groundbreaking discoveries, including the predictions of black holes and the expansion of the universe. Observations align closely with calculations, reinforcing the idea that the universe operates under consistent principles. This harmony between mathematics and the physical world suggests an underlying structure, prompting questions about the nature of existence itself. The reliance on mathematical reasoning implies a profound connection between the observer and the cosmos, reinforcing the significance of inquiry in the search for understanding. Cosmological models offer a structured way to understand the vast complexities of the universe. The Big Bang theory stands as a prevalent framework, positing that the cosmos originated from an extremely hot and dense state approximately 13.8 billion years ago. This initial singularity expanded rapidly, leading to the formation of galaxies, stars, and planets over eons. The expansion continues, evidenced by the redshift observed in distant galaxies, indicating that they are moving away from one another. Alternative models challenge this singular narrative. For instance, the steady-state theory suggests a perpetual creation of matter, maintaining a constant density as the universe expands. This model contends that the universe has no beginning or end, presenting a more static view of cosmic evolution. Other theories, such as the cyclic model, propose that the universe undergoes endless cycles of expansion and contraction. Each cycle culminates in a big crunch, followed by another Big Bang, suggesting a universe that is eternally reborn. These diverse perspectives highlight the ongoing quest for knowledge, where each model provides unique insights into the fundamental nature of reality. The interplay between these theories reflects the complexity of the cosmos and the observer's place within it, inviting further exploration and contemplation. Observational evidence plays a crucial role in supporting the anthropic principle, revealing patterns that suggest a universe finely tuned for life. This region of inquiry delves into the intricate aspects of physical constants and the specific conditions necessary for existence. Measurements of cosmic background radiation, for instance, indicate a uniformity that aligns with the requirements of a habitable universe. These findings raise questions about the implications of such precision. The values of fundamental forces, like gravity and electromagnetism, appear remarkably conducive to the emergence of complex structures. The delicate balance observed in these constants is not merely fortuitous, as it aligns with the anthropic perspective that life influences our understanding of the cosmos. Cosmological models further reinforce this viewpoint, suggesting that variations in the universe's expansion rate would lead to markedly different outcomes, potentially rendering life impossible. Statistical analyses of planetary systems indicate a narrow range of conditions where life can flourish, underscoring an inherent relationship between existence and the universe's characteristics. The convergence of these observations underscores a compelling narrative, one that intertwines the existence of conscious observers with the fabric of reality. Consequently, the anthropic principle becomes a lens through which the cosmos can be examined, revealing an underlying order that harmonizes the observer with the vast expanses of space and time. Human cognition plays a pivotal role in shaping cosmological interpretations, guiding the quest for understanding within the intricate fabric of the universe. This capacity for abstract thought allows individuals to formulate theories, question phenomena, and engage in deep contemplation of existence itself. Cognitive frameworks influence the perception of cosmic events, imbuing them with meaning that transcends mere observation. The complexities of this function become evident in the exploration of phenomena such as black holes and the cosmic microwave background radiation. These elements are not only subjects of scientific inquiry, but also reflections of the human desire to decipher the unknown. Interpretations of such phenomena have evolved, illustrating how thought patterns and scientific paradigms inform each other in a continuous dialogue. The interplay between observations and cognitive biases can lead to distinct theories about the universe's origin and destiny. Cultural backgrounds and individual experiences filter the information received, shaping unique perspectives on existence. In this context, the anthropic principle serves as a bridge connecting human inquiry with the cosmos. It invites contemplation on whether the universe's fundamental constants are fine-tuned for life, or if such beliefs are constructs of human cognition. The relationship between observer and universe remains a profound aspect of the quest for understanding, inviting further exploration into the nature of reality itself. Exploring the anthropic principle within ecological contexts reveals a nuanced interplay between life and its environment. This principle suggests that the universe's physical laws and constants are finely tuned for the emergence of life. Within ecosystems, the specific conditions that support biodiversity, temperature, atmospheric composition, and soil quality reflect an intricate balance. These elements coalesce to create habitats where organisms thrive, illustrating the principle's implications in biological settings. The delicate equilibrium observed in various biomes shows how life adapts to, and in some cases modifies, its surroundings. Coral reefs, for instance, flourish in particular temperature ranges and water clarity, demonstrating a precise alignment with the environmental parameters required for survival. The role of keystone species further emphasizes this relationship. Their presence or absence can drastically alter ecosystem dynamics, highlighting the interconnectedness of life forms within these habitats. Examining the Anthropocene epoch adds another layer. Human activity significantly impacts climate and biodiversity, raising questions about the sustainability of these delicate systems. The principle suggests that even minor alterations in environmental conditions can have cascading effects on ecological balance. Understanding these relationships fosters awareness of our role as observers and participants in this complex web, prompting reflection on responsibility and the stewardship of our planet. The implications of this awareness extend into the realm of future cosmological research, guiding inquiries into the fundamental nature of reality. Investigating the universe through the lens of the Anthropic Principle raises essential questions about the underlying mechanisms that govern cosmic evolution. The fine-tuning of physical constants becomes a focal point, suggesting that minute variations could yield vastly different outcomes in the formation of galaxies, stars, and planetary systems. This region of inquiry invites scientists to explore whether our existence is a mere coincidence or a product of specific conditions. These considerations may steer research towards understanding dark matter and dark energy, which constitute a substantial portion of the universe yet remain elusive. Insights into their properties could provide clarity on how these unseen forces interact with visible matter. Additional experiments and observations, such as those conducted with powerful telescopes, may reveal patterns that hint at the conditions required for life. The search for exoplanets in habitable zones exemplifies this trend, as researchers aim to identify worlds that might support life. Each discovery carries potential ramifications for our understanding of life's prevalence in the universe. Through these investigations, it becomes increasingly apparent that comprehending our cosmic environment influences not only scientific pursuits but also philosophical reflections on existence itself. Critiques of the Anthropic Principle arise from various philosophical and scientific perspectives. Some argue that it reflects a tautological nature, suggesting that the universe must be suitable for life simply because life exists to observe it. This reasoning can be perceived as circular, lacking predictive power, and failing to offer genuine explanations for the constants and conditions observed in nature. Alternative explanations emphasize the multiverse theory, proposing that countless universes exist with varying physical laws and constants. In this context, the Anthropic Principle may merely highlight our unique position within a vast array of possibilities, rather than implying purposeful design. The existence of life in one universe does not necessarily signify intention, but rather a statistical occurrence within an expansive framework. Philosophers also challenge the anthropic principle by questioning the implications of consciousness on reality. Some posit that the act of observation does not necessitate a designed universe, but may simply represent an emergent property of complex systems. The implications of fine-tuning, where certain physical constants appear remarkably suited for life, continue to generate discourse. In the scientific community, skepticism remains prevalent. Numerous researchers advocate for an exploration of naturalistic explanations that do not rely on anthropocentric assumptions. This ongoing debate reflects the intricate relationship between observation, existence, and the fundamental nature of reality. Alternative explanations for fine-tuning seek to elucidate the precise conditions that permit life as it is known. One prominent hypothesis involves the multiverse theory, positing the existence of numerous universes, each with varying physical constants and laws. Within this vast ensemble, it is suggested that only a select number of universes possess the necessary parameters for life, allowing observers to arise in those specific realms. This region of discourse challenges the notion that the universe must be uniquely designed for sentient beings. It proposes that the apparent fine-tuning observed in our universe may simply be a statistical outcome of an overwhelmingly larger landscape of possibilities, where the emergence of life is an incidental occurrence rather than an intentional design. Other theories consider the role of natural processes and mechanisms that could account for the specific values of fundamental constants. These include concepts such as self-organizing principles and natural selection on a cosmic scale, which may lead to conditions conducive to life without necessitating a designer. The intrinsic nature of physical laws might further support these explanations, suggesting that constants are not arbitrary, but rather manifestations of deeper yet to be discovered principles governing the cosmos. This evolving understanding prompts inquiries into the very foundations of existence, shaping the ongoing exploration of whether life is an inevitable outcome or a remarkable exception. Technological advancements have become pivotal in uncovering the complexities of the cosmos. Instruments such as the Hubble Space Telescope have provided unprecedented clarity, allowing researchers to observe distant galaxies and refine their understanding of cosmic expansion. Each new generation of equipment offers enhanced sensitivity, revealing phenomena that once lay hidden in the vastness. The development of radio telescopes has opened new avenues for exploration, detecting signals from the far reaches of the universe. These instruments can unveil the remnants of ancient cosmic events, shedding light on the formation of stars and the evolution of galaxies. Each data point collected provides insight into the conditions of the early universe, leading to a deeper comprehension of our own existence. Advanced computational models play a crucial role in interpreting observational data. They simulate complex interactions between matter and energy across vast scales, enabling scientists to test hypotheses against real-world observations. The intricate calculations help in understanding the subtle forces at play, from gravitational waves to dark matter, which influence the structure of the cosmos. As technology continues to evolve, so too does the potential for discovering new celestial phenomena. The quest for knowledge remains unrelenting, with each technological leap expanding the horizons of what is known. This ongoing journey into the depths of space invites reflection on humanity's place within this intricate cosmic framework. The Anthropic Principle introduces a profound consideration of scientific paradigms, suggesting that fundamental laws may be contingent on the existence of conscious observers. This concept challenges traditional views, prompting scientists to explore the implications of human existence within a universe governed by specific constants and conditions. These parameters appear finely tuned, allowing life to emerge in regions where conditions permit. The principle can be divided into two main forms: the weak anthropic principle, which posits that observations of the universe must be compatible with the conscious life that observes it, and the strong anthropic principle, which suggests that the universe must have properties that inevitably produce conscious life. This distinction highlights the interplay between observation and reality, raising questions about the nature of existence itself. In this context, it becomes essential to consider the implications for cosmology and physics. Theoretical models now often incorporate factors that address the existence of observers, influencing the development of multiverse theories, where countless universes with varying constants exist. These models provide a framework for understanding why our universe appears so remarkably suited for life. Klimo thwachuase, with why eich the body verify eich the philosophical shift, merging the empirical with the existential. The investigation of these ideas continues to illuminate the delicate balance between life and the cosmos. The interplay between science and philosophy and cosmology reveals profound questions regarding existence and consciousness. This region of inquiry delves into the fundamental nature of reality, examining how physical laws govern the universe while simultaneously raising existential reflections on the observer's role within it. Abstract concepts, such as the multiverse theory, suggest a vast landscape of potential realities, each with its own set of physical constants. The implications of such theories challenge the notion of a singular, objective reality. In this exploration, philosophical perspectives enrich scientific discourse, prompting critical examinations of concepts such as causality, determinism, and the nature of observation itself. The observer effect, a pivotal notion in quantum mechanics, underscores the influence of consciousness on the physical world, raising questions about the extent of knowledge and understanding. This intersection of disciplines encourages rigorous dialogue, as philosophical inquiry seeks to comprehend not only the mechanics of the universe, but also the meaning behind its very existence. Scientific advancements, such as the study of cosmic background radiation, provide empirical data that informs philosophical interpretations. Each discovery offers deeper insights into the universe's origin and structure, while simultaneously posing new questions that extend beyond the realm of empirical evidence. On a non-anthropic universe, the implications reverberate through both cosmology and philosophy. It suggests a reality indifferent to human existence, where the laws of physics operate independently of any observer. This absence of design challenges the notion of purpose, raising profound inquiries about the nature of existence itself. The vastness of space becomes a backdrop of chaotic events, encompassing stellar births and inevitable deaths, devoid of any intrinsic meaning. Such a perspective can lead to a more profound understanding of the universe's complexities. It invites exploration into the fundamental forces that govern celestial behavior, revealing intricate mechanisms that operate on scales far beyond human comprehension. These forces shape galaxies, regulating their formation and collapse over billions of years, illustrating a relentless march towards equilibrium. The concept of randomness emerges as a central theme, with quantum fluctuations and cosmic events contributing to an unpredictable reality. The absence of anthropic constraints encourages the pursuit of knowledge, urging scientists to decode the intricate patterns that arise from seemingly chaotic processes. This exploration fosters a deeper connection between observer and observed, revealing the fragile yet intricate web of interactions that constitute reality. The implications of such a universe prompt contemplation of humanity's place within this vast expanse, as well as the very nature of consciousness and its role in discerning the universe's mysteries. Statistical mechanics provides a framework for understanding complex systems by relating microscopic behavior to macroscopic phenomena. It forms a bridge between the individual particles that constitute matter and the larger structures they create. This perspective is crucial when examining the Anthropic Principle, as it highlights the probabilities underlying the conditions necessary for life. Aetions Anthropic, a universe that allows for observers, emerges from the intersection of chance and necessity. The vast array of potential physical laws and constants produces a landscape of possibilities, where only those configurations that support life reach the level of conscious inquiry. Such configurations may appear improbable, yet they exist within a statistical framework that embraces the myriad outcomes arising from initial conditions. Understanding these probabilities leads to reflections on the fine-tuning of constants, such as the strength of gravity or the electromagnetic force. The delicate balance of these forces suggests that the universe is not merely a chaotic expanse, but rather a finely calibrated environment. Each parameter impacts the emergence of complex systems, guiding evolution and fostering consciousness. This relationship between statistical mechanics and the Anthropic Principle underscores the significance of observers in shaping cosmic narratives. It frames existence not only as a random occurrence, but as a potential outcome within a richly textured continuum, inviting deeper inquiry into the nature of reality itself. This principle offers a lens through which to examine the evolutionary processes that shape life. The conditions necessary for life to flourish are often fine-tuned, suggesting a remarkable alignment between the fundamental constants of nature and the emergence of conscious beings. This relationship invites exploration into how certain traits may be favored, not solely due to survival advantages, but also because they enable a deeper comprehension of existence. In the grand scheme of evolution, adaptations occur through mechanisms like natural selection and genetic drift. These processes sculpt organisms, fostering traits that enhance reproductive success. Yet, when considering the anthropic perspective, the emergence of cognitive abilities and self-awareness appears to transcend mere survival. It raises questions regarding the role of consciousness in understanding the universe. The interplay between biology and the cosmos is intricate. The biochemical pathways that sustain life rely on elemental abundances, which in turn depend on cosmic phenomena such as stellar nucleosynthesis. This interdependence illustrates how the evolution of life is not an isolated event. Rather, it is a consequence of cosmic conditions that may have been finely calibrated to facilitate the emergence of observers. These insights reflect a profound connection between humanity and the universe, highlighting the delicate balance that allows for consciousness to arise amidst the vastness of reality. The interrelationship between consciousness and observational cosmology reveals intricate layers of understanding. This phenomenon suggests that conscious beings, through their ability to perceive and interpret, play a critical role in shaping the narrative of the cosmos. Observers do not merely exist within the universe, they actively engage with it, transforming abstract data into meaningful insights. The act of observation itself introduces an element of awareness, influencing the interpretation of cosmic phenomena. In this context, the observer effect becomes apparent, where the mere act of measurement alters the state of what is being measured. This interplay raises questions about the nature of reality, as it implies that objects in space may not possess definitive properties until they are observed. In this expansive framework, consciousness can be seen as a lens, refracting the complex interactions of matter and energy into comprehensible experiences. This process transcends mere observation and delves into the exploration of existence itself. The capacity for reflective thought allows for a deeper inquiry into the origins and structure of the universe. By engaging with the cosmos, conscious entities contribute to a collective understanding, enriching the ongoing dialogue about the fundamental nature of reality. Such considerations prompt a re-evaluation of the role of observers, suggesting an inherent significance within the cosmic narrative. Scientific realism faces significant implications from the Anthropic Principle, challenging traditional views on the nature of existence and the universe itself. The realization that certain physical constants and conditions appear finely tuned for the emergence of life brings forth questions regarding the inherent nature of reality. This principle indicates that the universe's parameters are not merely coincidental, but may reflect a deeper alignment with the conditions necessary for observers to exist. Tanuastui a truful tarmids asiantiv oldam. The understanding that observations are influenced by the existence of conscious entities introduces a layer of complexity to empirical research. Scientific models must account for the observer's role, recognizing that what is perceived is intricately connected to the conditions that allow for observation. This relationship raises the possibility that various interpretations of reality might coexist, shaped by the specific contexts in which observations occur. The implications extend to cosmology and particle physics, where the very foundations of these fields rely on objective measurements. A nuanced perspective emerges, suggesting that these measurements may be conditional, subject to the framework within which they are interpreted. Consequently, the quest for a singular, objective reality is complicated, as the universe itself may function as a medium tailored for conscious exploration. This understanding invites a careful re-evaluation of the philosophical underpinnings of science and the nature of truth within this vast cosmos. Theological perspectives regarding the Anthropic Principle evoke a spectrum of interpretations. Many theologians propose that the apparent fine-tuning of the universe suggests deliberate design. This notion implies that the conditions necessary for life are not merely coincidental, but indicative of a higher intelligence or divine creator. Such interpretations reinforce the belief in an intentional orchestration of cosmic events, where the laws of physics align in a manner conducive to the emergence of conscious beings. Contrasting viewpoints examine the Anthropic Principle within the framework of naturalism. These interpretations assert that life is a product of natural processes, with no necessity for a guiding hand. This perspective illuminates the concept that, among the potentially infinite universes that could exist, our own simply happens to support life. The odds of such an occurrence do not inherently necessitate a theological explanation. A third response recognizes the interplay between science and faith, suggesting that inquiry into the universe's origins can coexist with spiritual beliefs. This synthesis allows for a dialogue where scientific understanding informs religious thought and vice versa. Many believers find resonance in the idea that the very act of questioning the universe's nature is itself a reflection of the divine curiosity bestowed upon humanity. In this context, the Anthropic Principle serves as a bridge between scientific exploration and theological reflection, prompting deeper inquiry into existence itself. The Anthropic Principle has permeated popular culture, manifesting in literature, film, and even music. This concept has inspired creators to explore existential themes, often reflecting humanity's search for meaning within the vast cosmos. In novels, characters frequently grapple with their place in the universe, contemplating whether their existence holds a purpose beyond mere chance. These narratives invite readers to ponder the interplay of fate and free will, as well as the implications of a universe seemingly fine-tuned for life. In cinema, filmmakers have depicted the Anthropic Principle through intricate plots that challenge viewers to consider their own existence. Science fiction often incorporates this principle, presenting scenarios where characters encounter alternate realities or dimensions, questioning the very fabric of their reality. Such films provoke thought about the significance of life and the universal laws that govern it. Music, too, has echoed the sentiment of the Anthropic Principle. Composers occasionally weave in themes of existence and the cosmos, using sound to evoke feelings of wonder and introspection. Lyrics may delve into the interconnectedness of life and the universe, resonating with listeners who seek to understand their place in the grand scheme. This multifaceted exploration in popular culture serves as a reflection of humanity's innate curiosity about existence, as well as an acknowledgement of the mysteries that lie beyond. Scientific predictions arising from the Anthropic Principle suggest that the universe's physical constants and laws might be finely tuned to allow for the emergence of life. This tuning implies a remarkable balance, where even slight variations in these constants could render the formation of stars, planets, and V. Research in this field often involves the exploration of potential alternate universes, where different combinations of physical laws and constants may exist. In these scenarios, the emergence of life would be either hindered or rendered entirely improbable. The implications of this theory extend to cosmological models, influencing how scientists perceive the origins of the universe and its subsequent evolution. Predictions inspired by the Anthropic Principle have also impacted the study of dark energy and matter, prompting investigations into their roles in shaping cosmic structures. Observations of distant galaxies reveal patterns that support the notion of a universe designed with specific outcomes in mind. This perspective further encourages scientists to seek a broader understanding of the fundamental forces at play. In the end, the Anthropic Principle serves as a catalyst for inquiry, pushing the boundaries of knowledge and challenging the understanding of our existence within the cosmos. The quest for answers remains an enduring pursuit. The limits of human understanding of the universe shape the contours of inquiry in astrophysics and cosmology. Despite remarkable advancements, questions persist about the fundamental nature of reality. Observations reveal vast expanses, yet they often elude complete comprehension. This region, teeming with galaxies and dark matter, operates under physical laws that humanity is still unraveling. The observable universe extends approximately 13.8 billion years into the past, yet it is merely a fraction of the entire cosmos. This vastness presents both a challenge and a canvas for exploration. The interplay of forces, from gravity to electromagnetic interactions, governs the behavior of celestial bodies. Yet, even these principles hint at deeper mechanisms that remain hidden. It is within this complexity that the limitations of knowledge become apparent. Attempts to comprehend phenomena such as black holes or dark energy reveal the boundaries of current theories. While mathematics provides a framework for understanding, it often falls short of conveying the full essence of existence. The cosmic microwave background radiation, a relic of the early universe, offers insights into its infancy, but also raises further questions about cosmic inflation and the nature of time itself. In navigating these mysteries, humanity stands at the precipice of understanding, perpetually seeking clarity in the shadows of the unknown. All observers serve as the cornerstone of cosmological theories, providing the empirical evidence necessary to construct models of the universe. Each celestial event, whether the flickering light of a distant supernova or the subtle gravitational waves rippling through space-time, enriches the body of knowledge. These phenomena are not mere curiosities. They hold critical information about the fundamental forces and materials that sculpt the cosmos. Telescopes, both terrestrial and orbital, extend humanity's vision into the vast depths of space, revealing galaxies billions of light-years away. Data collected from these instruments contributes to a growing understanding of cosmic expansion, dark matter and dark energy, entities that remain elusive yet vital to the cosmic framework. The interplay between observation and theory illustrates a profound relationship, where each discovery prompts revisions to existing models, refining the narrative of the universe's evolution. In this intricate web of knowledge, it becomes evident that theories are not static. They evolve in response to new findings, revealing the dynamic nature of scientific inquiry. The quest for understanding is rooted in observation, as each empirical insight reshapes perceptions of reality. This process underscores the role of the observer, suggesting an interconnectedness between the cosmos and those who seek to comprehend it. The universe unfolds, and with every observation, humanity inches closer to grasping its vast, enigmatic essence. An ever-expanding horizon beckons, inviting exploration beyond the current boundaries of cosmological understanding. New frontiers emerge as technologies advance, enabling deeper insights into the structure and origin of the cosmos. Observatories equipped with cutting-edge instruments capture light from distant galaxies, revealing the intricate dance of dark matter and energy shaping the universe's fate. With every new discovery, the understanding of phenomena such as cosmic inflation and gravitational waves grows increasingly nuanced. These elusive signals serve as echoes from the very dawn of the universe, providing clues to its earliest moments. The integration of artificial intelligence in data analysis enhances the ability to process vast amounts of information, yielding patterns that were once buried beneath the noise of the universe. Interdisciplinary collaboration plays a pivotal role in this evolution. Physicists, astronomers, and mathematicians converge, merging theoretical frameworks with empirical evidence. This collaborative spirit fosters innovative models that challenge existing paradigms and stimulate fresh hypotheses about the nature of reality itself. Observations of exoplanets extend the search for life beyond Earth, revealing atmospheres that may harbor conditions suitable for habitation. Multidimensional studies of cosmic microwave background radiation continue to refine our comprehension of the universe's expansion. As such, the pursuit of knowledge remains an enduring journey, driven by curiosity and the quest to understand existence. The Anthropic Principle posits that the universe's fundamental parameters appear finely tuned for the emergence of life, particularly human observers. This notion raises profound questions regarding the nature of existence itself. In this context, the parameters of physics, such as the strength of gravitational and electromagnetic forces, seem remarkably conducive to the formation of galaxies, stars, and Several interpretations of this principle exist, with the weak anthropic principle suggesting that the universe must allow for observers to exist, while the strong anthropic principle implies a design-like quality to the cosmos. This divergence in thought influences scientific inquiry, prompting researchers to explore the conditions that allow life to thrive. The implications of these principles extend beyond mere curiosity, leading to investigations into cosmological constants and the fabric of reality itself. In examining various cosmological models, scientists grapple with the question of whether the universe is a unique entity or one of many in a vast multiverse. This exploration brings forth the notion that the laws governing existence may not be arbitrary, but rather a result of underlying principles that dictate the universe's structure and evolution. Investigations into this phenomenon continue to shape the landscape of modern astrophysics, inviting contemplation of the interplay between observer and observed. The ongoing journey through these inquiries reflects the intricate relationship between science and the fundamental questions of existence. Cosmic evolution presents a profound exploration of the interrelationship between life and the universe. The emergence of complex structures within the cosmos suggests a remarkable interplay of fundamental forces. Stars, formed from clouds of gas and dust, serve as the crucibles for the synthesis of heavier elements, These elements, in turn, coalesce into planets, creating environments ripe for the development of biological processes. Each planet's unique characteristics foster diverse ecosystems, demonstrating the adaptability of life in response to varying cosmic conditions. The intricate balance of forces governing celestial bodies influences the pathways that lead to habitability. As galaxies evolve, they undergo processes of formation and destruction, shaping the cosmic landscape. This ongoing transformation reflects not only the physical mechanisms at play, but also the potential for life to arise anew, time after time. The vastness of space offers countless opportunities for matter to assemble into life-sustaining forms, yet the rarity of such events adds a layer of complexity to the narrative. Exploring this interconnectedness reveals the delicate nature of existence within the universe. Each moment of cosmic evolution holds significance, intertwining the existence of life with the ever-expanding cosmos, prompting further inquiry into the nature of the universe itself. The delicate balance observed within physical constants raises profound philosophical questions. This finely tuned universe, characterized by precise values governing fundamental forces, suggests an underlying purpose or intention. Many theorists ponder whether these conditions are mere coincidences or indicative of a greater design. The implications extend beyond scientific inquiry, inviting discussions on existence, consciousness, and the role of observers. Contrasting perspectives emerge. Some advocate for the multiverse theory, positing an infinite number of universes, each with varying constants. In this view, our universe is simply one of many, with its unique attributes arising from random chance. The multiverse posits a vast expanse where the improbable becomes a reality, challenging notions of purpose and design. Others uphold the Anthropic Principle, asserting that the universe must exhibit properties that allow for the emergence of conscious observers. This viewpoint suggests a selective filter through which observers perceive reality, emphasizing the interconnectedness of existence and observation. The question of whether the universe is tailored for life invites contemplations about the nature of reality itself and humanity's place within it. As these philosophical inquiries unfold, they highlight the significance of consciousness, prompting deeper reflections on purpose and the intricacies of existence in this finely tuned environment. The conversation continues to evolve, bridging science and philosophy in pursuit of understanding. Artificial intelligence plays a transformative role in cosmological research, acting as a powerful tool for analysis and data interpretation. Vast quantities of astronomical data are generated daily, requiring sophisticated algorithms to process and extract meaningful patterns. This technology efficiently identifies anomalies in cosmic microwave background radiation, revealing insights into the early universe and its fundamental properties. Advanced machine learning techniques enable researchers to categorize celestial objects, from exoplanets to distant galaxies, far beyond traditional methods. They assist in predicting the behavior of complex systems, such as black hole mergers or the dynamics of galaxy formation. As simulations grow increasingly intricate, AI can enhance predictive models, refining our understanding of dark matter and dark energy. In this region of inquiry, AI does not merely serve as an analytical assistant, it becomes a collaborator, allowing scientists to formulate hypotheses and test theories with unprecedented speed. The integration of neural networks has led to breakthroughs in recognizing gravitational waves, marking significant milestones in the field. While the implications of these advancements are profound, ethical considerations also arise. Researchers must navigate the balance between computational efficiency and the need for human insight in interpreting results. The dialogue surrounding these issues continues to unfold, pointing to a future where artificial intelligence shapes the very foundation of our cosmological understanding. The emergence of life-friendly conditions on Earth illustrates the delicate balance required for the development of complex organisms. This planet's position within the habitable zone, often referred to as the Goldilocks zone, ensures temperatures conducive to liquid water, a critical component for life. It resides at an optimal distance from the Sun, allowing for stable climates that foster biodiversity. Geological processes further enhance this environment. Volcanic activity contributes essential gases to the atmosphere, while tectonic movements recycle nutrients and create varying habitats. Ocean currents distribute heat and nutrients, ensuring ecosystems thrive. These elements converge, establishing a rich tapestry of life, from the microscopic to the vast ecosystems of forests and oceans. This region of the cosmos also benefits from a protective magnetic field. It shields the surface from harmful solar and cosmic radiation, allowing life to flourish without constant exposure to destructive elements. The atmosphere, composed predominantly of nitrogen and oxygen, supports complex chemical processes essential for sustaining life. The interplay of these factors underscores a remarkable consistency in the development of life. While the question of intentionality remains philosophical, the conditions on Earth reflect an extraordinary convergence of elements. Such a scenario invites contemplation of the broader implications of existence and the intricate web of relationships that define life as we understand it. This perspective highlights the delicate balance required for life, particularly in the face of climatic shifts. The Anthropic Principle suggests that certain conditions are precisely suited for observers to emerge. This notion applies to Earth's climate, where slight variations can lead to profound changes in the environment. Understanding how these conditions evolved provides insights into the vulnerabilities that accompany such a finely tuned system. Atmospheric compositions and oceanic currents play critical roles in shaping ecosystems. The increasing concentration of greenhouse gases disrupts this equilibrium, leading to cascading effects on weather patterns and biodiversity. It becomes evident that the same principles that allow for the emergence of life also underpin its fragility. A rise in global temperatures influences not only terrestrial habitats, but also aquatic systems, affecting everything from coral reefs to polar ice caps. These changes raise questions about the sustainability of life as it adapts to new conditions. The interconnectivity of species within ecosystems becomes increasingly tenuous as shifts in climate impose stresses that can lead to extinction. In this context, the Anthropic Principle serves as a reminder of the responsibility inherent in being an observer. The choices made now will shape the future of this planet, influencing the legacy of life in an ever-evolving universe. The relationship between climate and existence remains a fundamental aspect of our understanding. The search for dark matter represents a significant frontier in modern astrophysics, influencing interpretations of the Anthropic Principle. This elusive substance, which is thought to comprise approximately 27% of the universe's total mass energy content, remains undetectable by conventional means. Its presence is inferred through gravitational effects on visible matter, radiation, and the large-scale structure of the cosmos. Understanding dark matter is crucial, as its properties may dictate the formation and evolution of galaxies. Within this framework, the Anthropic Principle suggests that certain cosmological conditions are conducive to the emergence of observers like humanity. The existence of dark matter could be integral to these conditions, influencing the formation of stars and galaxies in a manner that supports life. In regions where dark matter interacts with baryonic matter, gravitational clustering occurs, creating environments that allow for complex structures to arise. These structures, in turn, foster the conditions necessary for planetary systems. The implications of dark matter extend beyond mere composition. They challenge the very nature of reality and observation. Current observational efforts, ranging from direct detection experiments to astronomical surveys, aim to elucidate its properties. Each new finding adds depth to the ongoing inquiry into how the universe may be fine-tuned for life. revealing an intricate connection between the unseen and the observer. The mystery of time and observation shapes understanding in profound ways. It is perceived not merely as a linear progression but as a dimension intertwined with the fabric of existence. The concept of time dilation, where the passage of time varies based on relative speed and gravitational fields, illustrates these subtleties. Observers in different frames of reference experience time uniquely, highlighting the subjective nature of temporal reality. And the first and the third reality. In this realm, the observer's position becomes crucial. For instance, near massive celestial bodies, time slows, creating a disparity between those on the surface and those far from such gravitational influences. This divergence raises questions about the nature of reality itself, suggesting that perception is contingent upon one's location within the universe. The relationship between observers and the cosmos also extends to the measurement of cosmic events. Light from distant stars travels vast expanses, revealing phenomena that shaped the universe billions of years ago. The light captured by telescopes is not merely a reflection of the past, it is a testament to the unfolding narrative of existence. As the understanding of time evolves, so does the comprehension of the universe's structure. This relationship between temporal perception and observational reality forms a cornerstone of both philosophical inquiry and scientific exploration, guiding the quest for deeper truths about existence itself. The uncertainty principle introduces a profound layer to the discussion of observers and reality. At its core, it posits that certain pairs of physical properties, such as position and momentum, cannot be simultaneously measured with arbitrary precision. This intrinsic limitation challenges the classical notions of determinism and predictability, asserting that the act of observation fundamentally alters the state of the observed system. In this context, the observer becomes an integral component of the physical process. In quantum mechanics, this principle emphasizes the role of measurement, suggesting that reality is not merely an independent construct waiting to be discovered, but is instead contingent upon the observer's interaction with it. The implications stretch beyond the microcosm, reverberating through the macroscopic scale, where phenomena such as entanglement and superposition further complicate the nature of existence. In this framework, the boundaries of reality blur, revealing a universe that is interwoven with the threads of observation. Experimental outcomes can vary based on the observer's approach, leading to a spectrum of potential realities, each shaped by the intricacies of measurement. This interplay between observer and observed invites a contemplation of existence that transcends traditional understandings, positioning consciousness as a pivotal factor in the unfolding narrative of the universe. In this light, the quest for knowledge becomes not only an exploration of the cosmos, but also an inquiry into the nature of awareness itself. Albeit, the role of simulations in cosmic understanding reveals the intricate methods by which humanity deciphers the universe. These computational models allow for the manipulation of variables that govern physical laws, creating virtual environments where theoretical scenarios can be examined without the constraints of empirical limitations. Through simulations, complex phenomena such as galaxy formation, cosmic microwave background radiation, and dark matter interactions are rendered comprehensible, providing invaluable insights into the workings of the universe. In this realm of digital representation, vast datasets are analyzed to emulate processes that unfold over immense timescales. By mimicking these conditions, researchers can observe the evolution of cosmic structures and the interactions that shape them. The fidelity of such simulations often hinges on the accuracy of the underlying physics. Thus, they serve as a litmus test for existing theories and hypotheses. This approach has led to the refinement of our understanding of fundamental concepts, including gravity and the expansion of space, The continuous development of increasingly sophisticated algorithms enhances the ability to recreate cosmic events, allowing for the investigation of scenarios that remain unreachable through traditional observational methods. As these simulations evolve, they not only deepen comprehension but also challenge the very essence of reality and existence within this vast universe, prompting further reflection on the observer's place in the grand mosaic of cosmic history. The implications of the Anthropic Principle extend beyond philosophical contemplation, influencing the trajectory of space exploration, with a growing understanding that certain physical constants appear finely tuned for life. Missions are increasingly designed with this perspective in mind. Instruments and technologies are developed to assess habitability on distant worlds, focusing on environments that parallel those of Earth. Observations of exoplanets reveal atmospheres that might support life, guided by the principle that these conditions are not merely coincidental but potentially essential for observers. This region of inquiry also fuels advancements in astrobiology, where the quest for extraterrestrial organisms becomes intertwined with the fundamental questions of existence. Such explorations enable scientists to investigate how life might adapt under different cosmic conditions, opening avenues for understanding the universe's capacity to support diverse forms of life. Space missions are increasingly collaborative, drawing on insights from various disciplines to enhance the search for habitable zones. The Anthropic Principle nudges researchers to contemplate the significance of their findings, fostering a deeper connection between exploration and the essence of being. This evolving focus shapes not only the technologies employed, but also the philosophical framework guiding humanity's journey into the cosmos. The potential discovery of life elsewhere would not merely be a scientific triumph, but a profound affirmation of the intricate relationship between observer and universe. The exploration of this principle traverses multiple fields, intertwining cosmology, physics, philosophy, and biology. Each discipline contributes unique perspectives that deepen the understanding of existence. Cosmologists examine the parameters of the universe, identifying the specific conditions necessary for life to flourish. They analyze cosmic inflation and the fine-tuning of physical constants, which seem to align perfectly for biological evolution. Within physics, the inquiry delves into quantum mechanics and the nature of reality itself. These phenomena challenge conventional perceptions of observer influence, suggesting that consciousness might play a role in the unfolding of the cosmos. The implications ripple through philosophical discourse, where questions of purpose and intention are debated. Is the universe inherently indifferent, or does it exhibit characteristics that suggest a predilection for life? Biology brings a grounded perspective, focusing on the processes that sustain life. The intricate mechanisms of evolution reveal how organisms adapt to their environments, reflecting the interplay between life and the surrounding cosmos. This convergence of knowledge from diverse fields fosters a holistic view, illuminating the complex fabric of existence. The Anthropic Principle invites further investigation into the delicate balance between randomness and order, prompting a deeper appreciation for the conditions that support conscious observers within this vast expanse. It remains a profound inquiry into the nature of reality itself. The vastness of the universe invites contemplation on the human experience within its expanse. It encompasses countless galaxies, each housing billions of stars and potentially innumerable planets. This enormity contrasts sharply with the fleeting moments of individual existence. The human mind seeks understanding, striving to find meaning amidst the staggering scales of time and space. These reflections often lead to the realization that life, in its complexity, arises from a delicate interplay of conditions. The elements necessary for existence, including water, carbon, and a stable atmosphere, are not universally prevalent. This region of the cosmos, with its unique blend of physical constants, supports life. Observing the cosmos triggers questions about the nature of consciousness itself. Alpha No. It is curious to ponder the role of awareness in a universe so expansive yet seemingly indifferent. The existence of life raises further inquiries about purpose and significance. Each observer, with their own experiences and perceptions, contributes to a collective understanding of the cosmos, weaving a narrative through shared exploration. The intersection between science and philosophy becomes evident as these questions emerge. Each discovery, from the smallest particles to the largest structures, enriches the dialogue about existence. The thokosraposif of knowledge continues, grounded in a yearning to comprehend the cosmos and their place within it. This endeavor shapes the essence of the human experience, echoing through the vast corridors of time and space. The future of the Anthropic Principle invites a profound exploration of existence, intertwining scientific inquiry with philosophical reflection. As research advances, the implications of this principle may redefine fundamental understandings of the cosmos. It suggests that the universe's physical laws are not merely random occurrences, but potentially fine-tuned to foster the emergence of conscious observers. This notion raises pivotal questions about the nature of reality itself. Dull-lane in scientific circles, the Anthropic Principle could invigorate discussions surrounding cosmology and quantum mechanics. Observations from distant galaxies and the behavior of subatomic particles may provide further evidence supporting the idea that specific conditions must exist for life to thrive. These explorations may lead to a more nuanced comprehension of the universe's structure, potentially revealing hidden patterns within its vast expanse. Philosophically, the implications are equally profound. Questions regarding purpose and meaning may gain new relevance. The principle may challenge long-held assumptions about randomness and chaos, suggesting instead an inherent order. This could inspire a re-evaluation of humanity's place within the cosmos, prompting deeper reflection on the interconnectedness of existence. As researchers and thinkers delve into these ideas, the future may illuminate the delicate balance between science and philosophy, revealing the intricate relationship between observers and the universe they inhabit. The ongoing debate surrounding the universe and its observers continues to captivate minds across disciplines. Questions arise about the nature of reality and the role consciousness plays in the unfolding of cosmic phenomena. Investigations into fundamental laws of physics often intersect with philosophical inquiries, challenging established views and forming new paradigms. Each discovery, from the subatomic to the cosmological scale, prompts further exploration of existence's underlying principles. The fine-tuning observed in various constants and forces invites scrutiny as scientists seek to understand whether these conditions are mere coincidences or indicative of a deeper purpose. In this context, the Anthropic Principle stands as a focal point. It suggests that the universe appears remarkably tailored for the emergence of life, particularly intelligent observers. This notion raises profound implications about the nature of existence itself. Are these observations a product of chance, or do they hint at an intentional design embedded within the fabric of reality? Engagement in this dialogue fosters interdisciplinary collaboration, blending insights from physics, cosmology, and philosophy. The quest for understanding fuels a relentless pursuit of knowledge, as humanity grapples with the vastness of the universe and its own significance within it. With every inquiry, the relationship between observers and the cosmos becomes even more intricate, inviting further contemplation